Hello, ladies and gentlemen. I am Ibrahim Boy again, and as I promised, we will continue with the exposition of Maxwell equations. Because we are studying electromagnetism as a prerequisite for studying quantum mechanics. So, study of electricity is an age-old question, and many people have made their proposals. It was Maxwell's that came and put them together into four equations from which he calculated the exact speed of light and concluded that light is a kind of wave. He concluded that light is a kind of wave. Then Christian Huygens won the case over Newton, because there was a time when there was a disagreement between Sir Isaac Newton and Christian Huygens, where Huygens believed that light is a kind of wave, while on the other hand, Isaac Newton believed that light is a stream of particles equal corpuscles. We will see that maybe when Maxwell passed that verdict, Newton was not satisfied. He appealed, and quantum mechanics judged the case in such a way that neither of them was a culprit. So let us go. The divergence, we have taken the Maxwell equations for simplicity, for Maxwell equations in free space. Divergence. What is divergence? Let us assume this sphere is symmetrical. These arrows represent field lines. So divergence is how much a field spreads itself into space. So if this sphere is symmetrical, say like this, so as we know that lines of force are vectors, therefore they have direction. A vector in this direction will actually cancel a vector in this direction, so the entire vectors cancel out and you have 0 as the divergence of E in empty space where there is no charge around here. In charged materials, the first equation, Maxwell equation is stated as divergence of D, where D is electric field displacement in the conductor, is equal to rho over epsilon naught, where rho is the density of charges present and epsilon naught is the permittivity of empty space, or it may be epsilon, the permittivity of the material. So we have but this is far away from charges. This is what obtains. So forget about this one, because we are dealing with a situation whereby we are nowhere near electric charges. So can I have a duster? Yeah, I got one. So also the divergence of electric field, how expressed in space, is also a magnetic field. I mean, if you have a bar magnet, you cannot have a magnetic dipole the way you have electric dipole, like positive charge with divergence like this. A path divergence of a part of electric field may have a value. So this one is absolute divergence of electric field is equivalent to 0. So this one has only north and south pole. If you break it here, this will remain south pole, and this place will be a new north. Yes, a new north, and this point, end of this part, will be a new south. So you cannot, no matter how much you divide, you cannot have a magnetic monopole. And I said earlier, if you have a bar magnet, the field lines are somehow like this. Never mind my drawing. My drawing is very awkward. I am not good at drawing. So here you cannot have a divergence. So the divergence around this place taken all over, the absolute divergence of magnetic field is equal to 0. Let us go back to the sphere. Let's say the sphere is a piece of conducting wire closed. So it will set magnetic fields in opposite and perpendicular to the wire. So maybe a part may have a divergence, but the complete, if you take the complete integral of it, that is the integral of B dl, you get 0. Whenever you see an integral with a ring, it means an integration along a loop path. Then we come to equation 3. Curl of B is equal to the rate of change of E. Curl means rotation of a vector. Whenever a vector rotates and it produces another field perpendicular to it, then it would obey this law. We see pictures of black holes with a stream of electromagnetic radiation or something coming out of the center of the black hole. So that is the way it is. So the rate at which, the faster you rotate B, that means the faster you rotate a magnetic field, the faster the electric field changes. I think this is the principle that our generators and other appliances like electric fan and motor driving a record cassette in olden day devices. So how much you rotate this determines how much this changes. You have, in most cases, you have a big coil wound several times and a very large magnet connected to a shaft. This shaft is coming out of the blackboard. So the shaft may be connected to an internal combustion engine, may be connected to steam, may be connected to blades that are propelled by wind. It may be connected to blades that are connected to that lie on the path of steam or natural gas, or it will be connected, it may be connected, to the blades may be in water where a dam is constructed, so that when this is the ordinary flow of the river and a dam is produced like this, so the water has to collect a lot of more potential energy and pour down on this blade, rotating them and thereby rotating the magnet. So we have electricity. The same thing applies to electric field E. If you rotate electric field, it generates a magnetic field. There are important ways